Hello everyone. First of all, thank you for joining. I am Ankur Kumar. I'm a PhD candidate in the University of Alabama in Huntsville, and I'm working with NASA Impact as a graduate research assistant. So, just to give you the context of my talk, Hurricane Explorer, I'm doing my PhD on understanding the dynamics of hurricane, especially the hurricane rain bands during the post-landfall. So when I'm still working on a PhD thesis, I had to write the chunks of code every time again and again to read several data sets like reanalysis data set like metadata set or RFI data set. And then it's kind of a repetitive process. And then we thought to come up with a tool which you can use to understand the dynamics of hurricanes. And moreover, you can visualize the hurricane, but just visualizing the track and intensity cannot be the only purpose. It also has to be associated with some science aspect of this. So let me start with 101 lecture on hurricanes. I know most of you already work on hurricanes, but hurricanes, that is simply a low pressure system around which winds rotate in an anti-clockwise fashion. And some of the stratiform and the convective clouds, you can see those are the rain bands. And forecasting the hurricanes is always a complex problem since it involves atmospheric dynamics, prediction of atmospheric dynamics, cloud dynamics, and ocean dynamics. So that is why it's so important to understand the dynamics of hurricanes. So hurricanes are always associated with the giant storms. The radius of these storms can extend up to 500 kilometers, and the winds around which that can extend to 200 to 300 kilometers per hour. And once a hurricane forms over the ocean, it does make a landfall. And once it makes a landfall, then it will lead to several disasters like flooding or storm surge up to 20 to 30 meters. So to understand all the dynamics and the complex systems involved in the hurricane, we are coming up with a tool called HurrX. That's Hurricane Explorer. The good part about the Hurricane Explorer is you can able to access the data set from multiple reanalysis data set. For example, you can pick the RFI or MERA2 data set. And at the same time, if you are running your own numerical weather prediction models like WRF, you can able to read the data set directly from the WRF output. At the same time, if you want to read the data set from HUR, you can also do that. So on the right side, you can see the option for the year. You can pick any specific year, and this whole data set goes back to 1980. Because the source of this observed hurricane track and intensity is coming from the HurrX. That's the hurricane database. And down the line, we are going to add the functionalities to add the sources from IB tracks and ZTWC. So once you pick a specific year, then it will list out all the hurricanes for that specific year. And you can able to see the category for that and the formation date and the dissipation date, which is coming from HurrX. And when you click the animate, it will show you the track for that hurricane. But as I mentioned, visualizing just the track and intensity cannot be the only purpose for the tool. We want to add the huge aspect, which is the science aspect of this one. What we want our researchers to use this tool to understand the dynamics of the hurricanes. For this one, we do have to add the science aspect of this. Before I go and show the science aspect of this tool, I do want to mention that the RFI or MERA2 dataset and the HUR dataset, if you want to use to visualize these hurricanes, you do not have to download the dataset. All the dataset are on the cloud. Once you pick a specific hurricane, and based on the formation and the dissipation rate, it will already download the dataset in the backend, and then you can use it to show all the science plots. Moreover, and suppose, let's say you close the tool, you already downloaded some data set. Whenever you are going to use the tool next time, it will save all the data sets in the backend. That will store all the NetCDF files or SDF files, whatever you have for that hurricane. That will save the resources, and that will save the computation time too. So let's see, you pick a specific hurricane. In this case, I'm just showing an example from the Hurricane Ian. That's a Cat 4 hurricane. And it will come up with several visualization types, like you can able to visualize horizontal slice or vertical cross section or time series or hurricane intensity time series plots. And at the same time, if you have selected the MERA 2 or ERA 5 dataset, from the dataset itself, the tool will extract the information about the pressure levels. The tool will already extract the information about the selective variables and the timestamps too. The main purpose, because these tools are already, these data sets are already available out there. But if you want to use these data sets like MERA, ERA, or even the HUR, or if you are running your own visualization, own numerical models like WRF, it does take a toll. It does take a toll in writing the program to visualize those hurricanes. One of the major things which I do want to mention, that these dataset, MERA and HUR, these are the global model dataset. In case if you want to visualize for a specific hurricane, or if you want to visualize these datasets for a hurricane specific coordinate, you do have to write the code and you do have to go through the functionalities of cropping the dataset and converting to the hurricane coordinates. So this tool will do everything for you based on the starting date and the dissipation date from the HurrX dataset. So in the next a couple of minutes, let me go through some of the plots which you can, which you can plot by using this tool, and then I'll try to explain a little bit of dynamics for this. I don't want my Hyperwall talk to be a dynamics 2 lecture, but let's see. So this plot, you can able to see that's the time series plot for the mean sea level pressure and the wind speed. These two variables are simply how you define the hurricane intensity. So that's from the Hurricane Ian, and the animation which you are seeing, that's from the Hurricane Harvey. That is simply the track of Hurricane Harvey, and along with that, you can see the rain bands. Not the rain band, but the precipitation. And you can specifically, in some of the time steps, you can see the rain bands too, wherever it's available. Along with that, this is just the animation. And in case, if you want to do some time series analysis, you can able to plot these time series plots. One of the major things that all the plots are interactive. You can digitally zoom over these plots. This is just a time series plot, but in the next slides, we are going to take a look into the cross-section plots, and in that case, it's always a better option to digitally zoom those images. And moreover, whenever you plot some specific plot from this tool, it does plot at the same time. It's not like we are saving all the data sets, all the plots beforehand. Once you pick a specific variable, once you pick a specific timestamp and a level, it does plot those things in the back end. And plotting even a time series or a cross section, that usually takes maybe 1 second or hardly 2 seconds, but that is too much. That's 2 seconds is too much for generating the animation plot for 5 days or 6 days. So that's whenever you are picking a hurricane, whenever you are generating a plot, it does save all the plots interactively in the back end, so that whenever if you want to come again and want to see the data set or the plots, you can able to visualize those things quickly, and you are saving the resources at the same time. So the first one is the mean sea level pressure. The Hurricane Ian made the landfall on September 27th. So you can see in the mean sea level pressure, once it made the landfall, then the sea pressure reduces. You can expect the sea pressure to be at the lowest, and once it made the landfall, after that you can able to see the mean sea level pressure to be increasing. Same goes for the V component, that is simply the wind speed. And I have some other plots for the relative humidity at multiple levels, like 400 hectopascal, 700 and 1000 hectopascal. Once it make the landfall, then you can simply expect the relative humidity to be decreasing once it made the landfall, and you can see in the time series of the relative humidity. Again, this is some of the variables I am seeing, and some of the variables at some levels. But using the tool, you can able to you can plot all the time series plots for any specific variable for any level. Same goes for the vertical distribution of cross section. all the data set or the plots are in the hurricane coordinates. This means that at the center, you can see the center of hurricane, and the x coordinate is simply like the distance in kilometer away from the storm center. So in the first plot, you can see that the wind speed, and at the center of hurricane, that's a pretty calm region. That's called the eye of a hurricane. So over in the eye of the hurricane, you can expect the winds to be pretty low. You can expect it to have a very calm region. That's why you can see the wind speed values are almost zero at the center of hurricane. And around that, you can expect it to have a higher wind speed. That's the eye wall region. Similarly, you can see the vorticity, which is simply the curl of the velocity field. And in the eye of hurricane, you are expecting the vorticity to be like very high, which you can see in the vorticity cross section too. Similarly, I have the other plots for the wind speed. And for example, like in this plot, you can see the radial and tangential wind of the winds of the hurricane, which is simply like the secondary circulation, which you are expecting in a hurricane. And similarly goes for the vertical velocity. Not going deep into these each and every plot, but using the tool, you can generate for any specific variable and any time step. Similarly, I have some of the 2D plots overlapped with the wind vectors for wind speed and the mean sea level pressure. And since I mentioned, you already know this thing, cyclone or a hurricane, both are same. Is a low pressure system that you can clearly see in the special distribution of the mean sea level pressure. Similarly, the wind speed values are absolutely not completely zero, but close to zero at the center of hurricane. That you can see in the special distribution of the wind speed. In the distribution of 10 meter U and the V component, you can see the positive and the negative values, which are simply the radial wind on both the sides of a hurricane. In one direction, the winds is coming close to the hurricanes, but the wind vectors are different. And that is the distribution for the total precipitation. So that's the tool. You can use this tool to visualize any hurricane, and this is not specific to the hurricane. You can use this tool for hurricane, cyclone, typhoons, which are exactly the same, just the different names over different basins. So you can use this tool for any basin, for any hurricanes, or the cyclones, and you can use like any data set. So, and I do want to acknowledge the contributors, Anish, Paridhi, and Raj. Their contribution was mostly to develop the UI UX design and to convert my whole like chunks of code interactively so that you can do the plotting and everything. And I do want to acknowledge the contribution from George. He is somewhere in the audience. He's back there. His mostly contribution as a like science matter expert in our team who does contribute like what exactly functionalities we needed in the code. So that's it from my side, and I'm open to have any questions.